Hare Krishna students, welcome back to my channel. Today I'm going to teach you the topic finding LCM and HCF. In this we will first discuss what is LCM and what is HCF, and then the three methods of finding HCF and the three method of finding LCM. Okay, so let's get started. So very first we have to first discuss what are common multiples. So a number that is a multiple of 2 or more given number is called common multiple. For example, let's find out the common multiple of 3 and 5. So for that we have to list all the multiples of 3 and then the list of all the multiple of 5. Then we will see that in these list we have 15, which is common in the list of multiples of 3 and 5, and then 30 is also common. So hence these two numbers are the common multiples of 3 and 5, which is 15 and 13, and many more. We can find a lot of other common multiples as well, but out of all those common multiples, whatever is the least amongst them, so least common multiple among all the common multiples, is called the LCM. So if we talk about the LCM of the numbers 3 and 5, that will be 15, because 15 is the least common multiple among all the common multiples here. Okay, then let's start with the method of finding the LCM. The very first method is here listing multiples. Here this is similar to what we have just done. We're going to list the multiple of each number and then find the common multiple, and we have to list it until we get a common number, until we get a common multiple that is going to be the least common multiple. Let's see, let's try a question based on listing multiples method. Let's try write down the common multiples of 6, that is 6, 12, 18, 24. Let's write down the common multiple of 8, that is 8, 16, 24. Now you see 24 is common in both the lists. So we can say LCM of the number 6 and 8 is 24. Okay. Let's move to the another topic, another method, that is prime factorization. Let's go step by step. First step is to find the prime factorization of each number. If you don't know how to do the prime factorize, I've explained it in my previous video. I will share the link for that video in my description as well, so you can watch it and then come back to this. And then in the step 2, I will identify the highest power of each prime factor in the prime factorization. So first let's get started with the first step. First step is finding the prime factorization of each number. So first let's find out the prime factorization of 12. We can divide it by 2. 2 6 are 12, 2 3s are 6, and then 3 1s are 3. So we can write it as 2 times 2 times 3, or that can also be written as 2 times 2 times 3. Now find out the prime factorization of 18, that is 2 9s are 18, 3 3s are 9, and 3 1s are 3. This can be written as 2 times 3 to the power 2. Now what is given in the method? We have to identify the highest power of each prime factor in the prime factorization. So what is the highest power? See, and also with each prime factor. So each prime factors, we have only two factors here, 2 and 3. And for each prime factorization, what is the highest power for 2? It is here, that is 2. And highest power of 3 is also 2 in this one. So we are going to pick the highest power of each prime factor. So I'm emphasizing on each prime factor here. So that means we can't skip any factor here. We have to take each prime factor. Now we will multiply. So this will become 2 times 2 4, 3 times 3 9, 4 times 9 36. So 36 is the prime factor for 12, is the LCM for 12 and 18. Now let's move to other method, that is division method. So what is the step 1? Write the numbers in a row separated by commas. Divide the numbers by the smallest prime factor that divides at least one of them. So it's not necessary that your prime numbers should get divided by each the numbers. So let me first do it. Let's do it side by side. So first of all, we will separate the numbers by comma, and then we will see what is the step 2. Divide the number by the smallest prime factor that did at least one of them. If it divides all of them, that is also fine. Otherwise, it should divide at least one of them. So 2 is a prime number which divides all of them here. So we can take 2, 2 fours are 8, 6 are and 10s are. Again, you can divide it. 2 twos are 2 and 3 and 5. Now, amongst, see, there's no common factor you will get. So you can divide it by 2, and if this is 3 is not divisible by 2, we will write 3 as it is, 5 as it is, then we will do it with 3, 1 as it is, 3 ones are 3, 5 as it is, we'll write it 1, 1, 1, 1. Why I've reached to 1? Because this is in the step 4, that repeat the steps 2 and 3 until we reach to the until all the number reduce to 1, and the LCM is the product of all prime factors used in the division. So all the prime factors that are used in the division, if you do the product of them, that will be your LCM, right? So what is the LCM for these three numbers? You have to multiply all of them. 2 twos are 4, 4 twos are 8, 8, you can write 8 here, and 8 times 3 5s are 15, so 8 times 15, that is 120. 120 is the LCM for all the three numbers. Okay, so here are the three methods to find LCM. Let's see, let's try out few more questions. So for the first question, A part, I am doing it with the listing method. Let's list all the factors, all the multiples of 2. Now let's list all the multiples of 5. Now I'll just stop here only because I am getting a common multiple. So that is my least common multiple, which is 10 for 2 and 5. Okay. Now move to B. Now I'm going to do it with the prime factorization method. I'll do the prime factorization of factor of 8 and then 10. 2 4s are 2, 2s are, so that is 2 to the power 3, and this is 2 ones are 2, 2 5 sorry 2 5s are 10, and 5 5s are 1, so that is 2 times 5. So for LCM of this one, that is, we were going to take all like each prime factor and that too with its highest power, so that is 8 times 5, which is 40. So LCM of 8 and 10 is 40 here. Okay, let's try another question. Here I'm going to try the question number C with the third method, which is division method. Okay, so that is 6 and 4. I'll write it by separated by comma. So 2 3s are 6, 2 2s are 4. We can again do it with 2, 3 as it is 1. Now we divide it by 1. Now all the numbers are reduced to 1. So product of all these numbers will be the LCM. So that is 2 times 2 times 3, which is 4 times 3, that is 12. So 12 is the LCM for 6 and 4. Now D, E and F part I want you to try on your own and write the answer for these questions in the comment section. And for the second question, let's try second question here. It says, is it possible to find the highest common multiple of two or more numbers? So, what do you think about it? According to me, we cannot find the highest common multiple because we cannot even find the highest multiple of any number because that's an infinite series. So, we can't find the highest common multiple. Only the least common multiple is possible to find. Okay. Now let's move to the HCF. So HCF, first understand what are common factors. So common factor is a number that divides two numbers without leaving any remainder, and that should be other than 1, because 1 is the common factor of each and every number. But other than 1, if there is a number which divides two numbers completely without leaving any remainder, that is called the common factor. For example, let's take two numbers 12 and 18, and then factors of 12 are given as this 1 and 2 and 3, 4, 6 and 12. Factors of 18 are these. Now you can see in these two sequences you have common factor 2, common factor 3, and common factor 6. So common factors of this are 3, 6 and 2. So 2 and 3 and 6 are the common factors of 12 and 18. But amongst all the common factors of two numbers that we got, what is the highest? That is 6. So 6 is the highest highest among all the common factors. So that is nothing but the HCF. What does the name suggest? HCF means highest common factors. Okay, so highest common factor, highest number among all the common factors are called the HCF. So HCF of 12 and 18 here is 6. Okay, now let's see, let's move to the methods. So first method for this is prime factorization. Here we write each number as a product of its prime and identify the common prime factors. Here earlier we have taken the each prime factor in case of LCM, but in this we are going to take common prime factors only among all the numbers and multiply the common prime factors taking the lowest power. So this is the difference between the HCF and LCM. In LCM we have taken each prime factor, and in LCM we have taken each prime factor and their highest powers, but in HCF we are going to take the common factor only with their lowest powers. Okay, let's try one question. So if we have to find the HCF of two numbers 12 and 18, we have to do the prime factorization. 2 6 are, 2 3s are, 3 1s are. So we can now do it for 18. Okay, so I can write this one as 1 second. I can write for 12 as 2 to the power 2 times 3 and 2 times 3 to the power 2. For LCM we have taken the highest powers. For HCF we will take the lowest powers. So the common factor is 2 and 3. Both are the common factors here. So we can take both. But remember, only common factors we are going to take here. Now what is the least power for 2 here? 1. So we are going to take that. And what is the least power of 3? That is 1 amongst all. So 6 will be the HCF of that. Okay. Now let's move up to the next method, that is common division method. In common division method, step 1 is to find the common prime factor of all the numbers and then divide all the numbers by the common factor, write the quotient and repeat the process with the quotients until there are no common factors and the product of all the common divisors is the HCF. So we have to find a common prime here. We have to try the common prime factor of all the numbers. So let's try it with this only. So let's write it. Try to divide it with their common prime factor. That is, of course, 2 is the common prime factor for both of them. So this is 2 6 are, 9s are. Do we have another a number that divides both the number? That means a common factor. Yes, we do. That is 3. 3 2s are 6. 3 3s are 9. So do we still have any common factor which can divide 2 and 3 completely? No. So we will stop here only. So divide all the numbers by common factor and write the question and repeat the process with the question until there are no more common factors. So we don't have any common factors, so we have to stop now. And then the product of the common divisors is the HCF. So we will stop here only. In finding the HCF we will do the same method, but we will stop when we are reached to 1 and 1. Here we will have to stop here only because we don't have any further common factor. So we will just divide the common factors we got and the product of the these two common factors gives us the HCF. Okay. Now the third method is long division method. We will divide the larger number by the smaller number take the divisor from the previous step as the new dividend and then remainder as the new divisor. Let's try this out. So what is the larger number here? 18. I'm going to divide 18 by 12. This will go like this. 12 ones are 12. What is the remainder? 6. So what does the second step suggest? Take the divisor from the previous step as the new dividend and remainder as a new divisor. So this remainder I take as a new divisor, and this divisor from the previous one I take the new dividend. Now I'll divide it. This is 6 2s are 12 and I get the remainder 0. So repeat the step 2 until the remainder is 0, and the last non-zero divisor is the HCF. So what is the last non-zero divisor? That is 6. So HCF is 6 here. Right? Understood all the three methods? Okay, let's practice the questions now based on these three methods. So for the A part, we have to find the what was the first method? The prime factorization. So we will do the prime factorization of the uh, of 3, that is 3 only. 3 ones are 3, and the prime factorization of 6. Okay, A part is easy. You can do it. I will do the B part. Let's do the prime factorization of 24 and 16. So 2 and 12 and 2 and 6 and 2 and 3 and 3 and 1. I can write it as 2 cube time 3 for 16. This is 2 8s are 2, 4 2 2 and 2 1. So 16 can be written as 2 to the power 4. To find the HCF, we are going to take the common factor only, that is 2, because 3 is not here in this one. So I'm not going to take it. This is not a common factor. Only 2 is the common factor because 2 is there in both of them. Now, what is the least power of 2 amongst these two? That is 3. So 2 to the power 3, which is 8, is my HCF for 24 and 16. Okay, let's try another question with another method. Let's try 15 and 40 and common division method. Let's try 15 and 40. Is there any prime number that divides both of the number? 2 doesn't divide both of them. 3 doesn't divide. Yes, we have 5 which divides both of the numbers. So 5 3s are 15, 5 8s are this. Do we have any other number, any prime number that divides 3 and 8 both? No. So this method will stop here only, and this will give us HCF as 5. Okay, because we will stop until we get a common divisor here. And in the D part, let's try the long division method. So the bigger number is 70 and the smaller number is 42. I'm going to divide 70 by 42. Let's try it. 42 2s is 84. So this will go with 1 only. 42 ones are 42. What will be the remainder? The remainder here is, wait a minute. The remainder here is 10 minus 2, 8, and then 6 minus 4, 2, 28. Now this remainder is my new divisor, and this 42, which was the previous divisor, become my new dividend. Now let's see. 28 ones are 28, 28 twos are will be 56. So we'll do 1 by 28 ones are only. So let's subtract it. 12 minus 8, 4. 3 minus 2, 1. Now divide it by 28. Now 14 twos are 28 and we get a 0 remainder. So for whatever divisor my remainder is 0, that is my HCF. Okay, so for 42 and 70 the HCF is 14. Alright. Let's and then now rest of the question I leave it to you. You practice them on your own and write the answer in the comment section. Okay. Now this one is another question. What is the highest common factor of two different prime numbers? Give a reason for your answer. If you have two different prime numbers, 11 and 13, do they have any common factor? No. Because what is the What are the factors of 1? That is 1 and 11. What are the factors of 13? 1 and 11. Because prime numbers have two factors only, 1 and the number itself. So their highest common factor, if you talk about, that will be 1 only. Okay? Alright. Thank you for your time. Like and subscribe to my channel. Thank you.